We can find the voltage on the axis of a uniformly charged disk. It will have charge capital Q, radius big R. We're going to be a distance z along the axis away from it. To find that voltage, we're going to chop the disk up into lots of little rings because we have worked out in another video the voltage on the axis of a ring of charge. So to get the total voltage, we're going to have to add up all the little bits of voltage. So to imagine that formula working on a particular individual ring, big R is this radius, little a is going to be the radius of the ring under consideration. So instead of big R squared, we're going to have little a squared. And instead of total charge Q, we're just going to have dQ because that isn't the entire charge. That's just a little slice of it. Now, in order to work this out, we need to know what dQ is. And we can get that by noting that sigma is the total charge over total area. The area of the ring we are thinking about is 2 pi a dA. So a little bit of charge is sigma times d area. So it's big Q over pi big R squared times 2 pi little a dA. We can put that in for dQ. When we do, we get the voltage is going to be the integral from 0 to r of kq 2 little a dA over big R squared square root a squared plus z squared. So some of this doesn't depend on a, and we can pull it out front, 2kq over r squared. So we're left with this integral to do, a over square root a squared plus z squared. That turns out to just be square root of a squared plus z squared. So we can evaluate it from 0 to r. We plug in r, we get that. We plug in 0, we end up with square root of z squared, which is z, and we get our answer,